Good morning. It's John Gilkison here. It's Sunday, March 21st, um, 2021, and I wanted to shoot a short video on a scale model of the solar system. I just finished reading a book called First on the Moon. It was about Apollo 11, and it was written shortly after, around 1970, after the moon landing. And in the epilogue, in the back of the book, was written by Arthur C. Clarke. And that's an interesting epilogue in itself because he's talking about the future of rocket development in 1970, and he hadn't really envisioned Elon Musk at that time. But he came close. He talked about the problem. Anyway, near the end of the epilogue, he came up with a scale model of the solar system, which I thought was really interesting. And it involved using a record album, a long playing record album, which are about 12 inches in diameter. And the reason it intrigued me is because I've built two different models of the solar system. When I was running the teaching observatory in Denton, Texas from 1982 to 1986, I erected signs along a fence line. It was several hundred feet long, and each sign had legends about the planets or the asteroid belt or whatever, and they were spaced at the proper distance, so it was a scale model of the solar system. And when I left there, I took the sign down. But it was interesting. You could walk the whole fence line, and then the last sign said the planet Pluto is beyond the fence out there, and I think I had a marker out there for Pluto. And then I said, and the nearest star is in Santa Fe, New Mexico. And we were in Denton, Texas, so we're talking several hundred miles away. Then here, while I was doing programs for the National Public Observatory in the state parks, I created a scale model of the solar system for Rock Hound State Park. And it's still there. You can visit the park. Near the water tower, near the head office, is a series of signs which have the inner planets, and then you have to walk a path, and you walk a half mile or so to get out to Neptune, and everything's of course to scale. So that's interesting. But the thing about this scale model using a record album is something you can hold in your hand and you can look at, and it represents the whole solar system. And of course, it's like the solar system, it's a flat plane. You can imagine that, it's the ecliptic across there. Now, in this scale model, I'm using a pencil to hold this record, but this hole in the center of the record album represents the orbit of the Earth. Let me hold it back so you can see that. So the inner label, you could probably get the gas giants Jupiter and Saturn. I haven't worked with the scale on the record album itself that much. And that's because the distance between Mars, Jupiter, and Saturn is only 300 or 400 million miles. But then when you start to leap to Uranus, Neptune, and Pluto, these are a billion miles apart each, so the scale jumps quite a bit. So this is pretty good representation of it. I mean, double this hole in the center would be the orbit of Mars, and then not double, but anyway, the whole red label itself, you could probably fit Saturn in, and then the outer planets would fit in beyond there. And the sun would just be a speck of dust in the center. But because it's 1 foot in diameter, this gives us some interesting things to work with. I've arbitrarily set the, we'll put this pencil right here. I've arbitrarily set the diameter of the solar system to 10 light hours. In other words, it takes a beam of light 10 hours to cross the whole solar system. So that means the radius is 5 light hours. So 5 light hours turns out to be about 3.3 billion miles, which is approximately the average distance that Pluto is from the Sun. So 1 foot represents 10 light hours. That's 36,000 seconds. And hence, 1 light year equals 876 feet, which is 0.165909 of a mile. So on your scale model, keeping it in mind that 1 foot represents the whole solar system out to Pluto, 876 feet is the distance you have to walk to the nearest star. So it's 867 times further than the whole diameter of the solar system, to a light year. I'm sorry, I'm getting ahead of myself. So you'd have to multiply 876 feet times 4.2 light years in order to get to the distance to the nearest star. So Alpha Centaurus would be 69% of a mile. So it's 3,679 feet to Alpha Centaurus. And it's roughly 7/10 of a mile. So from there, you can make the leap to representing the whole galaxy. And again, we're just working around numbers, and it's really convenient. 10 light hours for the solar system, and the galaxy is 100,000 light years across, which works out to just around 16,591 miles, which is roughly 2 Earth diameters. So you can see, even with a solar system reduced down to this scale, just to represent the galaxy, we've already gotten to astronomical distances. So now the distances between galaxies compared to the distances between stars isn't that great, relatively speaking. So in other words, Andromeda Galaxy is about 25 galaxy diameters away. It's 2.5 million light years, and our galaxy is 100,000 light years across. So on this scale, Andromeda Galaxy would be 414,775 miles, which is about 1.7 moon Earth distances. The moon is 239,000 miles from the Earth, and 414,000 miles is 1.7 of those distances. So, and to get into the scale of the whole observable universe, of course, would be ridiculous. You would be back into astronomical distances that you could not conceive of in the first place, in either scale, even in the real scale or the scale of your model. So, as I've often pointed out to people, you can, driving at 60 miles per hour, it would take you 176 years to reach the sun. So we just don't have any concept of these distances relative to human scales. We just don't. And again, a lot of people overestimate the number of stars they think they see in the night sky. If they get to a really dark location, they think they're seeing millions of stars, and they're not. They're only seeing, you can't really see much more than about 5,000 to 6,000 stars at any one given time. And that's in the whole sky, so you're only seeing 2,000 or 3,000. And but anyway, if all the stars we can see were represented by grains of sand, all the stars that you can see with the naked eye would fit in a thimble, a sewing thimble, which fits on your finger. But to represent all the stars in the Milky Way Galaxy would take a dump truck. So I'm going to cut it short here. I'd like to get this uploaded. If you ever get a chance and you're visiting City of the Rocks in Faywood, New Mexico, it's a state park. The scale model of the solar system is there. But this is a really excellent scale model of the solar system in its own right. A long plane record out. And that hole in the center represents the orbit of the Earth around the sun. Good day, everybody. Happy astronomy trails. Bye.